Okay, today we will focus on momentum, grade 12 class. Now, momentum for grade 12. Now, momentum is a vector quantity with the same direction as the object's velocity. Now, momentum is a vector. Okay? You can pause the video here and just try to remember what is a vector and how it differs from a scalar. Okay, now momentum, now it means the momentum, it depends on the velocity because it has the same direction as the velocity. Now, okay, let me remind you the difference between the speed and the velocity. Now, what is a speed? A speed is the distance covered per unit time, whereas velocity is the rate at which the object is displaced. Now, speed is a scalar, meaning that speed doesn't have what? Doesn't have direction, it only have magnitude. Whereas velocity is a vector quantity, meaning that velocity has both magnitude and what? And direction. Now, the symbol of speed is v, but the symbol of velocity is v with an arrow on the top, meaning that it's a what? It's a vector quantity. Now, okay, let's continue. Now, momentum is defined as the product of an object's mass and velocity. Now, by looking at this definition, now you can even assume the formula, because if momentum is the product of an object's mass and velocity, it means already momentum, the formula is the product of mass and velocity. Now, momentum itself is represented by letter P with an arrow on top, meaning that momentum itself is a vector. Now, going forward, I want to tell you this now. P itself represents momentum. Now, again, according to this definition, you can see that now momentum itself is directly proportional to the mass. It means if you increase the mass, momentum will increase, meaning that the graph between momentum and mass is a straight line graph. They are increasing. Now, even the relationship between the momentum and velocity of the object. The relationship between momentum and velocity of the object is direct proportion, meaning that if momentum is increasing, even the velocity of the object will increase. Okay. It means if they tell you that momentum is increased or velocity is increased, it means even the momentum is what? It's increased. Meaning that the graphing between momentum and velocity will be straight line like this. Now, what is the change in momentum? The change in momentum depends on its initial value and its final value, which means momentum itself, change in momentum is equal to the final momentum minus the initial momentum. Now, going forward, you should remember from the earlier slide, I said momentum is equal to mass multiplied by velocity, meaning that we can write this as momentum is equal to mass final V final minus mass initial V initial. Remember, velocity is a vector. Now, if your mass is constant, if mass is constant, you can represent change in momentum as mass multiplied by velocity final minus velocity initial. Okay? Now this is only applied when mass is constant. Okay? If your mass changes, you will be forced to apply this one. Now, okay, let's continue. Now here is some example. Now this example is a very simple example. You can pause the video and try the example. Now the example is saying like a car has a momentum of 20,000 kg meter per second. What will the new car's momentum be if the mass is doubled by adding more passengers and a greater load and it travels at the same velocity? Now you can pause the video, try the example. Okay. Now, according to momentum, earlier we said momentum is equal to mass multiplied by velocity. Now, momentum is equal to mass multiplied by velocity, meaning that momentum is directly proportional to mass. And here on our example, the velocity didn't change. Now, meaning if you double the mass, your new momentum will be equal to double the old momentum, meaning that your new momentum will be 2 multiplied by 20,000, which will be 40,000 kg meter per second. Now, this example is very simple. You just have to remember that momentum is what? It's directly proportional to the mass. And if the velocity is not changed, it means if you double the mass, even the momentum will what? Will double. Very simple, straightforward example. Okay. Now, what will the velocity be if the momentum is 60,000 kg meter per second and the mass of the car is 2,000 kg? Now, in this example, the first keyword is this one. We are looking for the velocity. This is your unknown, which means velocity is our unknown. Our car's momentum is equal to 60,000 kg meter per second. Now, the car's mass, the mass is equal to 2,000 kg. Now, you can pause it here and continue with the example. Now, according to momentum, momentum is equal to mass times velocity, which means velocity is equal to momentum all over mass. Now your momentum is 60,000 kg meter per second. Mass is 2,000. kg. Now, meaning that we're going to have an answer of 30 meter per second. Now, this is it for that example. This example was very simple. A truck has a mass of 6,000 kg and it travels at 80 km per hour. How does the change in momentum, which means we're looking for the change in momentum here, if the truck is loaded with 1,200 kg and then it travels at 60 km per hour? You can pause the video and try the question The question is very simple. You can try it. Now, okay, in science, we know if we meet a question and it has a lot of things, what we have to do is to list our givens first. Okay, what is given? Let me write it down. Given. If you have a pen and a paper, you can write them with me. Now, the mass initial is 6,000 kg. Okay. Now, the V initial is equal to what? Our initial velocity is given as 80 kilometer per hour, which means this one we have to convert it to meters per second, which is 80 divided by 3,6. Now, don't have pride, press the calculator and get your answer. Now, this one is going to give you 22.22 meter per second. Now, mass final is going to be what? Now, worry on the final part. The truck is now loaded with 1,200 kg. The truck itself, its mass is 6,000 plus the load that is loaded, which is 1,200. This is going to give you 7,200 kg. Now, velocity final. Now your truck is moving at 60 kilometer per hour. This is converted to meter per seconds. Divide by 3,6. Remember, every time when you're converting to meter per seconds from kilometer per hour, you divide by 3.6. This is very important. Now, when you divide this by 3.6, it's going to give you 16,67 meter per second. Now, our page is full. You can copy your given. You can pause and copy the given. Then I have copied my givens too. I hope you did copy yours. Now, continuing from the last page, remember momentum is equal to mass times velocity. Now, I'm going to start with momentum final. Now, momentum final is going to be mass final multiplied by velocity final. Now, what is our mass final? It was 7,200 multiplied by our velocity, which will be 16,67. This is going to give us 120,024 kg meter per second. Now, momentum initial is going to be mass initial multiplied by velocity initial, which is equal to 6,000 multiplied by 22.22. This will give you 133,320 kg meter per second. Now, from that, we know that change in momentum itself is equal to momentum final minus momentum initial. The arrow represents that momentum is a vector. Now, meaning it's going to be 120,024 minus 133,320. which is going to give you a negative answer, but don't write the negative. The negative represent direction, and here we were not given directions, which means you just don't have to write the negative. 13,296 kg meter per second. Now, in this video, we learned about momentum, the change in momentum, how to calculate momentum, how to define momentum. Is momentum distinguished as a scalar or a vector? Now, on our next video, we'll continue from this video. We'll start with the change in momentum, then we will go forward with momentum. Can you subscribe and please check in for our next video? Thank you.